Everyone, this is Reshmi working as an assistant professor in Emmanuel JJ College of Engineering and Technology. Now I am here to tell you a few notes about the check dams. Now let's move on to the definition of the check dams. This is the picture of the check dam. So water storing areas. So a check dam is a small temporary or permanent barrier constructed across a drainage channel, stream or gully to reduce the velocity of flowing water, control soil erosion and promote the groundwater recharge. A check dam is a small barrier constructed across a gully, drainage channel or small stream to slow down the flow of runoff water, reduces erosion and trap the sediments. So this is the definition. Once again I repeat the definition. A check dam is a small temporary or permanent barrier constructed across a drainage channel, stream or gully to reduce the velocity of the flowing water, control the soil erosion and promote the groundwater recharge. So it is a gully, drainage channel or a small stream to slow down the flow of the runoff water. It may reduce the erosion and it may trap the sediment. From the picture I hope you all understand about the check dams. So next let's move on to the objectives of the check dams. The objectives is nothing, it's in a simple points. So to reduce the velocity of the runoff water, to control the gully and the soil erosion, to trap and retain the sediments carried by the runoff, to stabilize the gully bed and the banks, to increase the water infiltration into the soil, to conserve soil and moisture, to reduce the peak flow of the runoff, to improve the groundwater recharge, to prevent the further deepening and the widening of the gullies. The main objectives are to control the soil erosion in gullies and small streams, to reduce the water velocity and prevent scoring, to promote the sediment deposition, to increase the groundwater recharge, to stabilize the gully bed and the slope. Once again I repeat the objectives of the check dams: to reduce the velocity of the runoff water, to control the gully and the soil erosion, to trap and to retain the sediments carried by the runoff, to stabilize the gully bed and the banks, to increase the water infiltration into the soil, to conserve the soil and the moisture, to reduce the peak flow of the runoff, to improve the groundwater recharge, to prevent the further deepening and the widening of the gullies, to protect the agricultural land and the downstream structures, to control the soil erosion in gullies and small streams, to reduce the water velocity and prevent scoring, to promote the sediment deposition, increase the groundwater recharge, to stabilize the gully beds and the slopes. So now let's move on to the working principle of the check dam. A check dam is a small barrier constructed across a gully or a drainage channel, as we already seen in the definition part. So now the working principle of a check dam is based on reducing the velocity of flowing water, thereby controlling erosion and promoting the groundwater recharge. First is the collection of runoff. During rainfall, water flows over the land surface and enters the gully or drainage channel. As the runoff enters the area behind the check dam, its flow begins to slow. So reduction of the flow velocity. The check dam acts as an obstruction to flowing water. This reduces the velocity and erosive force of the runoff, thereby protecting the gully bed and the side slopes. When a runoff water flows through a gully or a small stream, it has a high velocity which causes the soil erosion. So next is the temporary storage of water. Water accumulates temporarily behind the check dam. This creates a small ponding area and increase the time available for water to interact with the soil. In sediment deposition, when the velocity of water decreases, its ability to carry soil particles also decreases. Sand, silt, and other sediments settle behind the check dam. As the velocity increases, it may happen when it decreases. The carrying capacity of water reduces. Suspend the soil particles settle down. Sediment get deposited behind the dam. So first is the collection of runoff. During rainfall, water flows over the land surface and enters the gully or drainage channel. As the runoff enters the area behind the check dam, its flow begins to slow. So, reduction of flow velocity. The check dam acts as an obstruction to flowing water. This reduces the velocity and the erosive force of the runoff, thereby protecting the gully bed and the side slopes. Sediment depression. Temporary storage of water. Water accumulates temporarily behind the check dam. This creates a small ponding area and increases the time available for water to interact with the soil. Sediment deposition. When the velocity of water decreases, its ability to carry soil particles also decreases. Sand, silt, and other sediments settle behind the check dams. Sediment deposit. As the velocity decreases, the carrying capacity of water reduces. Suspended soil particles settle down. Sediments get deposited behind the dam. So next is the infiltration of water. So increase in infiltration, the temporarily stored water gets more time to infiltrate into the surrounding soil. This improves soil moisture and can contribute to groundwater recharge and to contribute to groundwater recharge. Remains for a longer duration, percolates into the soil, recharge the groundwater table. The temporarily stored water gets more time to infiltrate into the surrounding soil. This improves soil moisture and can contribute to groundwater recharge. Safe passage of excess water. When the water level rises, excess water passes safely over the cluster through the designed outlet or opening of the structure. Proper design prevents uncontrolled overflow and structural damage. Uncontrolled overflow and structural damage. When the water level rises, excess water passes safely over the cluster through the designed outlet or opening of the structure. Proper design prevents uncontrolled overflow and structural damage. So, infiltration of water, it may temporarily stored water gets more time to infiltrate into the surrounding soil. This improves soil moisture and can contribute to groundwater recharge. Safe passage of excess water. When the water level rises, the crust or through the designed outlet or openings of the structure. Proper design prevents uncontrolled overflow and structural damage. Slope stabilization of the gully bed. The sediment accumulated behind the check dam gradually rises the gully bed. This reduces the effective slope and help prevent further deepening of the gully. So this is the stabilization of gully bed. The effective slope of the channel decreases. Flow become non-negative. Long-term stabilization of the gully occurs as flow, stabilization of gully banks and stabilization of gully bed. In stabilization of gully bed, the sediment accumulates behind the check dam gradually rises the gully bed. This reduces the effective slope and help prevent further deepening of the gully. In the stabilization of gully banks, as flow velocity decreases, erosion of the gully banks is reduced. Vegetation can also establish in the deposited sediment, providing additional protections. So the effect of a series of check dams in long or steep gullies, several check dams may be constructed at suitable intervals. Each structure reduces the energy of the water, creating a step-like sequence that controls the erosion throughout the gullies. So when we write in a flow sequence, first of all we write it a rainfall. When there is a rainfall, there may be a runoff. When there is a runoff, the check dams and reduce to the velocity, temporary water storage, next to the sediment deposition, and then next to infiltration, and then safe overflow, next gully stabilization. So the basic principle of a check dam is to reduce the energy of flowing water by slowing runoff and allowing sediment deposition and infiltration. Check dams help control soil erosion, conserve water, stabilize gullies, and protect the downstream areas. So now let's move on to the types of the check dam. There are two types of check dams. One is based on permanency and next is the based on the materials used. So other types may also be there. Brushwood check dam, loose stone check dam, log check dam, gabion check dam, masonry check dam, concrete check dam, earth check dam. So let's move to short notes about these check dams. So brushwood check dam is made from the branches, brushwood and wooden stacks, suitable for small gullies and low runoff. Usually a temporary structure, helps reduce low velocity and trap the sediment. Loose stone check dam is constructed using locally available stones placed across the gully. It is simple and economical. It is suitable for a small and moderately flowing gullies. Allow some water to pass through the spaces between the stones. So log check dam, it is constructed using a wooden logs or poles. Logs are firmly fixed across the gully, useful in areas where timber is readily available, generally used for temporary erosion control. Gabion check dam, made using wire mesh baskets filled with stones, strong and flexible, suitable for gullies with relatively high runoff, can withstand some movement without complete failure. Masonry check dam, constructed using stone masonry with a cement mortar, strong and durable, used for permanent gully control, suitable where runoff is comparatively high. Concrete check dam, constructed using concrete, sometimes reinforced with steel, highly durable and suitable for heavy runoff. Requires proper design and foundation, used where long-term protection is required. Earth check dam, constructed using compacted soil or earth, generally used where runoff is relatively low. It requires a proper compaction and protection against the overflow reaction. So from our PPT, type of check dam is divided into two types, based on permanency and based on material used. First, in based on permanency, there are two types of check dams. One is temporary check dams, and next is permanent check dam. So based on permanence, check dams are mainly classified into two types. Temporary check dam, these are constructed from short-term erosion control and are generally made for locally available materials. It is used in small gullies. It may be of low cost and easy to construct. It is suitable for initial erosion control. Some of the examples of temporary check dams are brushwood check dam, log check dam, straw or grass barriers, low stone check dam. And the features of the temporary check dams are it is very easy and inexpensive to construct, suitable for small gullies and low to moderate runoff, have a relatively short service life, help control erosion until vegetation becomes established. Next is permanent check dams. These are designed for long-term gully and erosion control and are constructed using stronger materials. So the examples are masonry check dam, gabion check dams, concrete check dam, and the features are it is too short and it is very durable, suitable for higher runoff condition, require proper design, foundation and construction, provide long-term stabilization of gully bed and banks. So next is the based on material used, and based on material used there is loose rock check dams, earthen check dam, masonry check dam and concrete check dam. So brushwood check dams first is made from branches, twigs and wooden stakes, used mainly in small gullies. Usually temporary in nature, helps reduce runoff velocity and trap the sediment. And low stone check dams, it is constructed using locally available stones or rocks, simple and economical, suitable for small and moderately flowing gullies. It is constructed using locally available stones, suitable for small streams, allow some seepage through the stones. So once again I repeat it, constructed using locally available stones or rocks. It is very simple and it is economical, suitable for small and moderately flowing gullies. It is constructed using locally available stones, suitable for small streams, allows small seepage through the stones. So next is the against log check dam, made using wooden logs, poles and sticks. Logs are placed across the gully and secured firmly, generally used as a temporary structure. In earthen check dam, constructed using soil or compact earth, suitable for areas with low runoff, requires proper compaction and protection against overflow. Constructed using compacted soil, suitable for low discharge areas, requires proper compaction and protection. So gabion check dam, made of wire mesh boxes filled with stones. It is strong, flexible and durable, suitable for moderate to high runoff. Masonry check dams, constructed using stone, brick and cement mortar, strong and suitable for permanent erosion control, requires a stable foundation. It is constructed using bricks or stones with cement mortar, strong and permanent, suitable for medium sized streams. So concrete struck dams, made mainly from plain or reinforced concrete, very strong and durable, used where runoff and erosion forces are high. So now again I repeat the definition of the check dam. A check dam is a small, temporary, permanent or permanent barrier constructed across a drainage channel, stream or gully to reduce the velocity of the flowing water, control soil erosion and promote the groundwater recharge. I hope you all understand about the types of check dams, definition, its working principle, and its main two types. Based on the two types, it is divided into 6 to 7 types. So I hope you all understand. Thank you all.